transfer. Okay, so I'm going to show you guys a number of different OWASP tools and some of the research I'm doing and some of the progress I've been doing on some of the, trying to, testing is doing, trying to figure out how to solve the application security problem. Since I actually talked about static analysis, I would actually show you very quickly what O2 has from a point of view of static analysis. Because I think ironically, when I kind of went and developed the O2 platform, and basically the O2 platform is what I think most of you guys would develop if you had enough time and you were crazy enough and you stopped working commercially for about 2 years, I think you would arrive at something like that, right? It's basically a massive prototyping engine, right? And that's why I call it to automate application security, right? And my first objective was to automate me, right? And I was able to do that. Now the challenge is to make sure you guys can automate yourselves, right? So I get to the point where I'm exponentially faster when I script using O2 than I do in any other tools, right? And I think that it's not the fact that you need to use O2, but I think the concept and what I'm trying to create with the O2 platform is where I feel the industry needs to go, right? And my biggest problem is that the industry is still buying PDFs instead of buying automation. It's really frustrating the fact that we still hear seeing about PMD, right? And it's not just its problem, it's the fact that the commercial tools still haven't come out of the closet, right? Which is kind of ridiculous. When we actually need this technology to be used by everybody, right? And I was working in Analyse Labs, if you guys remember that one, who got bought by IBM, right? And I decided not to become an IBM employee because they had no idea what I was doing. So I left, right? And they still don't, right? It's ridiculous, right? 3 years later, they still, IBM is still not ready for the stuff I was doing with their tool 3 years ago, right? Same thing with Fortify. Now I'm integrating with Checkmarks. I'm integrating with a couple of others. And I want to show you some stuff with cat.net. But the first thing I want to show you is following up on the concept that Justin talked about, the sources and sinks, right? If you guys open up the O2 platform, right, and the O2 platform looks like this when it starts up. So it's basically, again, it's the dump of my brain, right? And the thing about the O2 platform is you guys will get lost trying to use it. So the best thing is you have a target, you try to use it, and then drop a thing to the mailing list. And then I probably could point you to a blog post, because there's about 250 blog posts. So, there's a lot of documentation out there. What there is the first step, right? And the way I look at it is that, in a way, is a community responsibility. My job is to make sure that the O2 platform, it's a really good platform, right? And it's still, very rough on the edges. But the first thing I want to show you is what I call the method streams, right? Which is actually, it's actually a static analysis engine, right? And in fact, actually probably before that, I'll show you cat.net. You guys know what cat.net is? Who here uses .net? Kind of. All right, so cat.net is criminal if you guys aren't using it, because it actually is a really decent static analysis engine, right? What happened was cat.net got into a cat fight with FXCOP, right? FXCOP won. So you guys hear about FXCOP, you don't hear about cat.net, but the reality is cat.net is 10 times better than FXCOP. Because cat.net actually does tape flow analysis, actually does inter and inter-procedure analysis, right? And it's actually really easy to customize, right? So what I've done was usually you run cat.net in Visual Studio, so I found a way to extract cat.net and run it as a standalone application. So this is actually a standalone application that you guys can run that actually allows you to drag and drop a DLL. For example, let me just grab one, right? Let me start a clean one, right? But you can basically drag and drop a DLL from a compiled, where is my little web goat? There you go. No, not that. This one. Yep, .NET Goat, sorry. So I'm actually going to show you .NET Goat, which is a cool new variation of web goat. Like you got the web goat for Java, now you got the .NET Goat. So basically you can see that that was cat.net running kind of as standalone, and I can now grab the compiled DLL, which is basically this one here. So this DLL here is actually the compiled DLL of the cat.net, sorry, of web goat for .NET. I drag and drop, and he's going to do a full-blown static analysis, right? This is exactly what Jess was talking about for .NET. Right? And this is really powerful because this will find most of your low-hanging fruit, right? And it will actually do it with actually inter procedures. And basically, you can see here, it actually gives you a nice trace that follows across, let me find a nice juicy one, multiple files. So you can actually see, well, this actually follows the same file. Let me see if there's one here that does multiple files. Actually, where, ironically, okay, that one. Okay, so here's an example, right, of why static analysis is really powerful, because it's really good at reducing false positives, right? So in this case, you can see that I'm grabbing a request get string. That's a basically tainted value, comes from the outside world. He now calls this guy, calls that guy. He's going to call this internal method, right? Find source person. So basically, the point of following taint analysis is the engine knows that that string is now tainted. Basically, that string now came from the outside world, and if he finds a place that he knows is a problem, then it gives you vulnerability, right? Now, what's interesting about this, right, is that this application, which is basically the web goat for .NET, is riddled with SQL injections, right? But actually, you see that there's only actually one here, right? And in fact, I'll take the rule out, so you can actually see A, how fast this whole thing is, B, the blind spots. So I'm going to come in here, I'm going to go into this is basically the rules here, which is pretty cool. Basically, this is an XML-driven rules, right? So I can actually write my rules in XML. So I'm going to go to my SQL injection, and I'm just going to quickly comment that guy out, so then I can actually show you the problem. So, so I save this, I rerun the scan again, and that vulnerability is going to disappear, right? It's pretty fast, it's pretty cool. See, there it goes, the SQL injection is gone, right? And now, very quickly, what I've done was I added a new sync, right? So what I've done was I went in here and I said I want to have a new sync of type manage on actually this bit here and basically on the get customer details. Now this is the bit where every single static analysis fails, right? And exactly a great example of why I say, and you guys read my blogs, that one of the key things about static analysis is gluing traces, right? If you guys actually follow this on here, right, and if you actually look at that vulnerability, which you get customer details, you would actually see that get customer details, the one that is found by the tracing is actually this one here, that one, which is actually an interface, right? This is where it gets interesting, right? And actually, in this case, they actually have two implementations. Usually there's more. So the point is, which one is vulnerable? Which is why you actually have to glue the traces, because you need to now create one from the other end. So what you actually have here is, you have the first part of the trace, which is the trace from the get parameter to the interface. What you actually now need to do is you need to tell the engine that actually this is a callback, right? So now we need to get a trace that treats get customer details as a tainted variable. And then you're going to follow all the way to the SQL connection. Now again, cat.net doesn't find it because it doesn't have support for the MySQL and doesn't have support to the SQLite database, right? So these are the things you need to do. This is why I always say that static analysis needs customization. Without customization, you have very little visibility, right? So if you guys are clients, can you please put pressure on the vendor static analysis, because they still don't buy the idea that you need to customize. They still want to sell the big button that doesn't work, right? And it's your fault. It's your clients, it's your fault. Because you are the ones that should be demanding better from the vendors. You are allowing the vendors to get away with selling you products that doesn't support this, right? When in reality, we should be having a great discussion and mapping of all these rules, taking the stuff that Justin is doing, taking this stuff which is already there, and actually figuring out open source rules for how we connect all this stuff. And workflows, and ways to talk, and ways to integrate with the IDEs. And who mentioned the Sonar thing? Who was the guy who mentioned Sonar? I think Sonar was great, right? I'm actually trying to integrate with Sonar, right, on one of my commercial products I'm working on, because I think it's a great thing. And yeah, take into account that there's no such thing as OWASP compliant, but there's such thing as finding vulnerabilities that match the OWASP top 10, right? So it's kind of like it's almost like the order of you say things, right? You cannot be compliant with the OWASP top 10, but you can find things from the OWASP top 10, right? Now, this is cat.net. Again, if you guys are not using it, it's almost criminal, right? In fact, you are irresponsible. Because if you find stuff on your app, basically I go to the point where it's drag and drop. I actually wrote a plugin for Visual Studio. You can actually control Visual Studio in real time using your tool. So you can create all sorts of crazy stuff in there, and it's actually some guidance available. And the rules are easy to manage, right? But the reason it still looks like this is because there's been no traction. Because I posted stuff out there, and I'm still one of you guys who use it, right? So please try to use it, and it's free, right? Microsoft has gave up on it, but I think it's one of the best things that Microsoft has created in a long time. And actually, Mark Cuffey was one of the guys involved, so it's a great connection with OWASP. What I wanted to show you is, so cat.net, you guys seen it? There's actually a pretty cool stuff in O2 for cat.net. Even from a, if you guys search here, there's cat.net, all sorts of scripts. So this is actually a great one, which is one of my favorite ones, which is, where's the real time? I think it's this one. Nope, not that one. Or is it that one? So, no, that's a variation of that. Actually shows the different findings. The one I wanted was, I think it's this one. No, this is a different one. So, okay, I'm not going to show you because I can't find it. So, but it's actually, unfortunately not online, or else I'll actually show you the whole thing running in real time. There you go. Just a matter of, if I was online, I would actually use Google to find it. All right. Now, this is for, actually I showed this before, right? This for me is the future of static analysis, right? What you have here is you have real-time compilation and detection of tamed flow static analysis, right? So to give you an idea, what's happening here is I'm actually using, I'm basically, every time I type a keystroke, right, I'm actually compiling the code, right, and I'm running a cat.net scanner, okay? So you can see that, for example, this is a tamed variable, right? This basically, that comes from the outside world, right? And this is a script. This is like a Roslyn or a kind of O2 kind of scriptified, where you get to just practice, right? So you can see that if the tainted value goes into response.write, you have a process scripting, right? If it goes into a redirect, you have a redirect user control. If it goes into a process start, you have a process start execution. And if it goes into an open read, right, you have that. I think this is great to try the engine. This is great to actually understand how static analysis actually works, right? The other thing that's really cool about this is you can also see the differences between the different type of encoders. And in fact, cat.net is reasonably clever on this because it actually allows to set an encoder for a type of vulnerability. So it actually means that you can say, if I go virus safe equals to context.server.html encode, right? And now I got my taint. Right. So again, the nice thing of static analysis is that if you did a grep on the code for this, you might say, hey, this is great, they're using HTML encode. Where the point is the fact that there is a variable that goes from there to there. Right? So at the moment, the vulnerability still exists. The vulnerability stops to exist once I do this. Right? Now, right, in fact, actually interesting there, sorry. For my safe, and now you can see, right, that my vulnerability, my cross-site scripting disappeared. Okay? Now, the interesting thing of here is you can see that the other ones didn't, right? And I'm using the same variable. And the reason the other ones didn't is because the actual encoder is set for cross-site scripting, not for the others, which is, again, is very important. Right? Again, this is pretty cool, works in real time. You have a couple of sample files here, you've got a couple of snippets with just cross-site scripting. You got, this is a blind spot, this is an implementation of the problem you had before, where there's actually a vulnerability here, but you won't find it because it's on an interface, so it's a pretty cool thing. So yeah, running in real time, this is what we want developers to have. I want developers to be coding, they create a vulnerability, poof, something appears there. Right? It's like, by the way, do you realize that you just created this? Right? And this is what we should be doing, right? And we're still not there because static analysis technology is still not widely used. Now, if you guys wanted to create a static analysis engine, right, you actually have 90% of it in O2, right? And the way it looks like is this thing called method streams. And the method stream is basically something which is, I'll actually show you method stream, which is, I think, a really cool innovation that I was implementing in O2, and I did it because I was doing lots of code reviews, right? So the thing that you need to realize is O2 is developed based on somebody's problem, right? And a lot of time it was me or sometimes of O2 users, We scared me for a second. And so a method stream is something that is absolutely invaluable if you're doing, right, any kind of code review, right? So a method stream, it's a single file that has, at least it works for .NET, and I wish we had this for the other technologies, but you know, if you want the blueprint, but everything is here is open source, so if you guys want to implement it in Java, it's actually pretty easy. So the method stream is one file that has all the dependent methods from the starting point, right? Now, if you think about it, how you review code, right? In fact, the best example I had was a guy who once told me that he actually did this on paper, where what he did was he printed out the whole source code, he cut out every single method that existed on the source code, and then he manually put them on the floor, and then he read the code. Now, if you think that's crazy, it's actually one of the most efficient ways to evaluate a source code. And I'll give you an example where I use this. I was giving a 500K line of code. The brief was find any vulnerabilities with the web services, which is like a little bit of the code. Of course, my question was, can you point me to the code that's used by the web services, right? And of course, the developers were like, good luck, and let me know if you find it, right? And of course, the problem was they had like 500 SQL stored procedures. 20 of those were vulnerable to SQL injection, right? Now the problem is, you can't go to them and say, fix these 20, right? Especially because there's code that depends on that. What you have to do is say, well, of the web services that I'm analyzing, I was able to map to these 2 stored procedures. And that's the ones that I think you guys should fix. And the only way I was able to do that is I created a method stream from the web service all the way down. So you can see here that what's basically happening is compare passwords, right? Let me actually see if I can find one from the outside world. So let's say one of these guys. And actually one of these pages, which is, there might be, this is actually the, what's it called? This is actually the code from, webgo.net. So let's say you got this method, right? Get products and answers, right? So you can see that this method calls this guy, and that guy, right? So you can see that those methods are now below, right? So this file has everything, right? And including here, you got there's an SQL injection, right? There you go. There's an SQL injection. In fact, probably not. Actually, it's not because it's actually in there, right? But that would be an SQL injection, right? So this is the basis of static analysis. In fact, what's great about this is that you can actually look at the code, and if you see anything missing, you go, oh, the engine doesn't have enough visibility because the code should be here. So you can actually think of this as code coverage on steroids. Because if you look at a bit of code, and suddenly that you know that thing goes to the database and that code is not there, you know you have some code missing that you're going to have to go and hunt. And all this is scripted. There's an API to do this. I actually create custom APIs where I actually throw more stuff in there, like if there's an XML parser or stuff like that, I'll throw it in there, right? So now let me show you, and this one's here that I'm showing you is basically generated. So this was actually kind of, because some of this is quite expensive, I actually ran a tool, another O2 script that calculates all the method streams, because there's some cost. And it'd be cool if we actually do this on the cloud, right? On Git commit, create the method streams, that'd be pretty cool, right? So, if you guys want to see the method stream created in action, I'll show you a good example here using what's it called? Happy Bank, very quickly. So this is a good example of how it works. So you can see, you open the tool, method streams creator, and just to reinforce the concept, right? That tool, method stream creator, is a script. So this is kind of Python-y, but it's like a strongly typed Python. Okay, I almost rewrote O2 in Python, but I didn't like the lack of strongly types. So eventually I kind of went back to .NET and come up with what was probably very equivalent to kind of Python with jQuery, right? And now Angular, kind of all thrown together, right? Okay, so what I'm going to do here is I'm going to drag and drop that. So you can see that this is a good example because you can see that, look, if you look at let's say, the SQL engine, right? The SQL engine has all the SQL methods, right? SQL execute, yada, yada. The data factory has all the data factory methods, yada, 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 right? And then you got the web service, who basically calls, most web services calls the data factory, who calls the SQL thingy, who calls the database, right? So what's powerful about this is you can pick one of these methods, right? And once you select the methods, on the right here, you are going to see the method stream, right? So this is the method stream. So you can see there's my post message. The post message calls this guy. That guy actually creates the concatenation. There's a concatenation. Then that calls this one, who calls the SQL statement, etc. So all the code is there. And what was really cool was, I remember talking to John Stevens, right, if you guys know from Digital, and I always was against doing static analysis engine because I always thought it was very hard. But once I created this, I was like, I already have everything I need for static analysis engines. All I need to do is follow the actual variables, which already have the ASD. So that's exactly what I did here. So now on the right, you can see that I can also follow and identify you the actual variables as they go through the thing. So basically that is what static analysis does. It's basically following assignments throughout, right, the multiple levels of the code, right? So if you guys want, to build a static analysis engine, this is 90% of what you need, right? All it's needed is rules and some GUI and kind of a nice and drag and drop, a big button, and then a nice, rules interface. Which is why I stopped developing this and went for cat.net, because I think that if we're going to develop rules, we might as well do it there, right? But this is still an amazing resource for code reviews, and it's basically, I think, the foundation of static analysis. Okay, now let's now take a step back into the stuff I wanted to show you, which is, well, this is O2, right? But first of all, I want to show you a couple of things on what's it called? On the AppSensor project, right? So now, how many guys here know about the AppSensor? Okay, that's another big trick you guys missing, right? Because AppSensor is one of the, it's an amazing hidden gem of OWASP, right? Now, I don't know if you guys heard of ISAPI, right? And ISAPI, the idea is an enterprise security API, but it's supposed to be a framework to develop an API. AppSensor is the same concept, right? So AppSensor is the idea that your applications should be behaving differently depending if they are under attack or not under attack. That your application should know what's going on with the application. Your application should basically have a little brain there that if you have, for example, a huge number of login attempts, failed login attempts, some alert should be generated. If you have patterns of activity that are kind of odd to what the application normally behaves, you should have alerts being created. Right? If you have SQL injection payloads arriving on a particular page where usually the users don't make that mistake, then you should have an alert. And the whole point of this, in a way, the great concept of AppSensor is it provides a great framework for how to think about that. It provides a great framework for how to actually do the intrusion detection, how to actually, what kind of rules should you be triggered. And if I was online, I would show you the website, right? And Colin actually has created some great documentation and stuff that it actually puts in there. Oops. Now, my interest was, I'm on the .NET world, right? So for a while, I couldn't consume AppSensor, right? So what I've done was, using O2, I was able to consume Java directly from .NET, right? Which is pretty cool. So I can now, from .NET, I can fire up a JVM on the same process, right? And consume Java jobs, right? What's really cool about this is this, for example, allows me to do something that I've always wanted to do for a very, very long time, which is basically this. Which is, where are we? I think it's this one. And here we go. So I'm currently working on this product called Team Mentor, where basically I develop the application. So this is kind of the back end of it. So basically this is the .NET application, right? So it kind of looks like this, and typical .NET app, right? Bunch of guidance stuff. So what first thing I want to show you guys is this, right? Okay, so this is the Java JVM system properties, right? On a .NET process. Okay, so this is pretty cool, right? Because it means that I'm talking to the JVM, right? I'm having a direct conversation with JVM, right? And also this is very powerful for me because in O2 I have a really amazing fast prototyping environment that when I go to Java and the other apps, I lose. So I always want to use that quick prototyping environment from O2. So basically, now that's the Java properties. Kind of more interesting is this, right? So these are all the jars currently loaded in the jar file, right, in the class path. So that's all the jars that are currently loaded. So this, you have to imagine that now you have a process that has both a CLR and a JVM on the same process. And I'm using GNI bridge, so GNI to .NET, which is basically the same thing as JBridge, right? Now, and you can see I get all the metadata from all the Java classes that exist in here. Now, a much more practical application, which is one of the reasons I was late, right, was I wanted to do this, which is basically the SAPI encoding, right? And now this is something that I've been trying to do for 3 years. Every time I saw the amazing work that the guys at the SAPI did on the encodings, I wanted to create a standard for what do we call encoding for HTML, encoding for XML, encoding for XSS, for VBScript, for LDAP, etc. Right? And the problem was I couldn't touch it because somebody was in .NET, somebody's in .NET, somebody's in Java. So now we actually got it all in the same place. So what's interesting about this, right, is the actual transformations are actually done by Java, right? The actual transformations are actually done on the SAPI jar, right? But I'm showing you a .NET environment, and I can actually invoke it again from the O2 environment, which actually O2 is running on the back end, right? I'm actually using O2 APIs. What's interesting about this is, like, again, from a secure development point of view, right? A lot of times, the guidance is, oh, you have cross-site scripting, just encode it, right? So just run HTML encoded, and you'll be good, right? The problem is, HTML encode, there's a huge amount of blind spots, right? Because you might have, something like this, which might actually look quite benign, or even just something like that, right? Which actually some HTML encoders would actually allow. But the problem is, depends on where you are, right? You actually, okay, maybe just a little jQuery, right? This actually, if you look at this, right? For example, right? Depending on how you encode it, it actually SAPI does a good job, right? Because if I actually turn around and I show you the default .NET encodings, you'll see that it's very different. So if I go, so this is bollocks, I should be online, and I'm not. Okay, so that's one of the things. So if you see that in O2, what it means is that usually you need to be online, and there's a couple of extra dependencies that get downloaded. I'm offline. I can't show you. But the point is that, for example, in .NET or in Java, a lot of, for example, this would actually pass the HTML encoding, because the HTML encoding would be looking for the brackets instead of actually looking for all sorts of different characters, right? And this is actually, in a way, this shows you the different types of encoding that you need to do depending on where you need the payload to be, right? So in this way, you can see that there's a big difference between if your payload for XSS is on the middle of HTML, which is kind of where it's okay, if it's an attribute where you need to do this, or XSS and JavaScript, etc. And one of the things is, like, your app needs to support this, right? The point is that if you look at an application that you're developing or testing, and there's no way, or currently you don't see any difference between encodings, right? You know they're going to have problems. Because, HTML encode is not good enough. And in fact, sometimes URL encode is not good enough, right? So this is a good example. And what I was done here was I was able to consume it from .NET and Java, which actually is basically what I really wanted, was now to create find, for example, a mapping between anti-XSS and now this one, the SAPI ones, and the AppSensor ones, and also create a set of unit tests that you can plug to your app. So you can go, well, this is my views, here are my payloads, and this is the test I should be running. So the whole point of where I'm going with this is to create what I would call it the SAPI, which is the testing API for security. That's what we really need. We need basically a testing API that you guys can hook these unit tests into your app, and then you can basically do the testing. Okay, so now you can see that I'm already in .NET, I'm consuming Java, which is pretty cool, right? So the next thing I was able to do is I can also now access the AppSensor logs, right? So this is actually a list of the logs that actually are created by AppSensor, and now I already have a way to create a log and then I can actually consume it there, right? So again, for the guys who were at the last time me and Colin did this is already another step forward, right? So now what I start to have here is I have to have the ability to reuse the thinking behind AppSensor into how the app that I'm developing is going to develop this. And of course, I'm not going to do this in production, but my point is to create interfaces that represent the behavior that the app should have, right? And I think that when you look at complex apps, like the one I'm developing at the moment, in fact, all the issues are open, you can see how complex, even something like user management, password resets, encoding is in the real world, right? And a lot of times, the real solution is actually to allow the vulnerable state, but to add a layer of detection. So the real solution sometimes is we are going to have to allow username brute force. We are going to have to allow password brute force. Because the alternative, right, is to allow the attacker to block our accounts, which we don't want. So how do you handle that? We basically handle with things like AppSensor. We handle by modifying the behavior of the app so that basically the app behaves differently if it's under attack or not. So I think that's a pretty cool evolution. And I think if you look at some of the better apps out there, they already start to have some of that behavior, right? So AppSensor is definitely a project I would highly recommend you guys take a look at. Right? And basically study it, look at how the attack points and the thinking that's going behind the attack points is really good. So from my point of view, I don't need to think about adding more attack points. I'm worried about re-implementing that on the app that I'm doing, where I'm now currently developer in there. Okay. So next thing is I want to show you guys Zap, right? So who here uses Zap, right? Okay. So Zap it's basically a proxy tool, right? So let me show you. Okay, by the way, the other thing that you got, too, you got basically a gazillion of installers, right? So if you search for installers, basically every other tool that I needed, there's like a little installer for it, right? So one of them is now Zap, which I added a couple days ago. So if you guys just search for Zap, there's going to be refresh. There you go. There you go. And this is actually just run Zap. This would actually, if you do it on a clean box, download the latest version and just fire it up. Now, Zap has gone a long way, right? And basically, Zap is two things, right? It's a web proxy, so it shows you all the traffic. In fact, I would say three things. It's a web proxy. It already has some automation in terms of scanning, and it has a really nice API to access it, right? So from my point of view, where I'm really excited about Zap is actually the API, because I always found that the problem with black box analysis tools is that I need to be able to control what they do. I want to it's almost like having these attack dogs, right? And I want to let them go gently, not here it is, and then go loose. So the API that Zap has for me is really interesting because it's going to allow all sorts of cool behavior and automation of tests, which actually again is what we really need to be doing, right? So I'm going to fire up WebGoat. So you guys can see WebGoat here, and WebGoat, okay, just open that from here, and some projects. Where's my thing? Okay, I'll just find it from here. So, and WebGoat is actually, it needs a bit of love, but it's actually, there's a lot of cool foundations in there, right? So, I'm just going to fire it up. And I'm going to basically let Zap loose on WebGoat so you guys can see, sorry, on webgoat.net, so you can see some of these functionalities. Right? So, this is got a .NET tool, and I'm going to just fire up the, go on. Oh yeah, and by the way, there's, the O2 development environment, you can actually have access from here, right? So you can actually control all of Visual Studio directly from here. So I can actually code Visual Studio in real time from here. Okay, let me just quickly fire up this guy. Start without debugging. So Zap has, there's this thing now here that you can basically give it to attack, which is a very interesting feature. It actually doesn't work with different ports, but you can say go and attack that particular site. So I actually need to first give it a little example of where the Here we go. So I'm going to point this to the site, and where is my webgoat.net? There you go. So you can see that webgoat kind of follows the same pattern of the normal webgoat, where you have lessons and you have details and you have injection attacks and you got SQL messages and you got little tips for the thingies, which is pretty cool, right? So again, it's a great learning tool. If you want to get developers to really get their heads around application security, it's a great learning tool to go through it. And what I think is interesting is also try to fix it, right? Because fixing code is actually much harder than exploiting it. So I think I want to have a parallel project on GitHub that is actually a fixed version of webgoat, right? So I'm going to basically point it to a particular thing, and you can see that it's nice and readable with SQL injections, right? And you can just log in like that if you wanted to, with nice SQL injection. And oh, actually I need to do it here. That helps. And now, in principle, yeah. Okay. So it might be the proxies not set. Just a second. Tools, options, my proxy. Yep. Okay. So Firefox. Oh. Yeah, weird. Options. Yeah, look at my proxy set. That's a bit weird. Why? There you go, the demo gods.
Change the proxy port.
Well, it's 88, right? This guy is on.
Yeah, Firefox.
Oh, is he 81?
Yeah, change it.
Oh, see that? Oh, you did. You're right. I'm sorry. That one is a little swearing. Big enough to screw up. All right. Now, are you still not happy with that? How many minutes here? All right, 88.
I think you got it because you got HTTP, just local push.
Yeah, because it was redirecting to the other one.
No, inside it, where you got your proxy set.
Oh, it was to.
Yeah, you got it as HTTP ://localhost. Why it should be just localhost or
Like that?
yeah.
Talk about.
There you go.
Yeah, that's a great usability, right? Yeah, to allow me to actually put data that doesn't make any sense in there. All right. Okay. So, okay, you can see that he goes into here, right? He goes into Zap. Zap is there, right? He finds the stuff. So you can basically. So one of the cool things he has, you can see I can log in. I can go there. I'm logged in. So now I got the page there, right? And so now what's cool about this, you can actually now go to this is the kind of like go and be crazy, right? Attack this thing, right? So you could say go there, attack stuff, and it has this pretty little cool thing that will give you a little kind of sequence of events, right? Of actually what attacked. I think I took a bunch of stuff off, so I was actually modifying the attacks. So I took all I just left the SQL injection because I was trying to find the SQL injection, but I think he's one of these guys. Oh, scan policy, there you go. Right? So here, you can see that he already has a whole bunch of stuff that he can basically go and try to find, and then more to be written, right? So it's pretty sweet, right? And you can see there's my tests going through, right? So I'm just gonna stop it, and then run it again. Try this guy. So it's actually pretty sweet, right? So it's already started to find stuff, and if you get alerts, they show up here on this thing here, right? Of course, the demo gods are now happy, right? But it actually works reasonably well. One of the things that I want to do is that I want to script this, right? This is exactly my point, right? What happens is what we do is we hack away, we get it to work. what I really want is I want to have a script that really does this, right? And one of the things that Zap allows you to, which is for me the best part of Zap, is this. So if you actually go into, right, the 8080 port directly, you got this cool thing, right? In fact, I think you could even just go Zap, which is a nice little touch, right? Or a Zap 8080. I think. Right, there you go. There you go. So now what's cool about this is basically it's a full-blown REST API that allows you to, you can see, invoke stuff, get things, get results, and it all comes in JSON stuff. So you can get like, the scope. There was a really cool one, like you get all the URLs. So it's a really, really interesting, what's it called? Set of data, and I think there's a huge amount of potential here. It's actually one of the best APIs I've seen from this point of view, right? So the point is to now start to write unit tests that trigger this, so you can actually use Zap to basically do the abuse cases. It also has a Selenium kind of plugin, which is pretty good. So the idea is that you write your unit tests that do the browser automation, you feed it to basically to a proxy, and then you start to go, well, test this, well, test that, test this. Right? And what I want to do is when there's a problem discovered, I want to have a unit test just for that issue. So that when the issue is fixed, you run that unit test and that then goes through. Right? So that's basically Zap, which is pretty interesting. I definitely recommend you guys to take a look at. The last thing I want to show you is another on the kind of the research that I think it's important that we figure out how to do. Is one of the things I've done, again, like late last year on the O2 platform, is I found a way to actually hijack Windows, right? And this is actually pretty spectacular. Right? Like I actually use this as part of my day job, right? Basically, what this means is that, I don't know if you guys know Windows, right? It's basically a Windows environment, right? So the way Windows works is everything on a desktop is a window, right? Including buttons, including links, including inner things, right? Including the command prompt. So what you got here is a little GUI that allows you to hijack, right, a particular window, like that, right? And you can restore it, right? So I can restore it. But I can also not just hijack that, I can also hijack like controls, right? So there you go. So now that control is inside my process, right? But what's cool about this, right, is that it's not inside, in a way, it's not inside the process. It's just under the process control because it's still running natively, right? So for example, if you look at this, I'm going to open the equivalent of that one with 4 little hosts. So I got 4 of those dudes, right? So you can see that what I'm going to do here is I'm going to find Zap, right? And Zap, I'm going to basically make sure I got Zap, right? And I think that's Zap. There you go. So now I got Zap there, right? Which is Java, right? I'm going to basically grab Chrome, which is this guy here, right? Which is C++. So I'm going to go here. I'm going to grab Chrome. There's my Chrome. And it's always good to just take a little screenshot to make sure that you're actually getting the right thing. There's my Chrome. So you can see the window disappeared from there. It's now here, right? And then you can actually go, if you wanted to, you can go to Visual Studio, right? And you can grab, a source code from Visual Studio. So I can go in here. I can grab one of those guys over there, right? And there you go. That's my hijack Visual Studio. And then you can also, grab another one from here and, oops, where is it? And what's cool about this, right? This environment is you can now start to think, what is the environment that I want to create to a developer, right? So I've done things where I create a GUI where I can put all the information that is relevant to a particular issue in one place that I can actually control and automate. And I'm now not limited to the fact that the original window is from Java or .NET or C++ or whatever. As long as there's a Windows, then I can grab it, right? And there's a bunch of blog posts about it, and I think this is a really cool innovation that O2 has, and I actually use this almost every single day. For example, to put Chrome inside Visual Studio natively, right? Which is pretty cool. Actually, I put Chrome, IE, and Firefox inside Visual Studio natively, which is pretty cool, right? All right, guys. So there you go. So you guys kind of real world tour of a bunch of OWASP tools. It'd be cool if you guys can help. All this stuff is open source. So AppSensor, Zap, O2 platform. in webgo.net, they're all open source, and it's a great way for you guys to contribute and participate. Thank you.